Hello everyone, I am Alex, CEO and leader of the architects team at Lexart. Today I'll talk about DAST in modern pipelines from a graph theory and the state space perspective. Before I start, DAST means Dynamic Application Security Testing. It is a security method that finds vulnerability in running application by simulating real-world attacks from an external black box perspective without needing to access to the source code. Now, just to the point, when we run a dusting pipeline, we usually interpret that the application was scanned and no critical vulnerability were detected. But what actually happens is that non-characterized fraction of the system possible behavior was explored. Now we can model a modern application in the following way. We define a directed graph G, defined as the set V and E, where V is the set of observable state of the system, and E represent the possible transition between states, request, event, or callback. Just to remember that directed graph is a set of nodes connected by oriented edge, where each edge represents one-way relationship or transition from one node to another. The next important point is that HTTP endpoint is not a node, but a state transition function. This is because an HTTP endpoint takes the system from one state to another depending on the input and the context. So now we need to understand why status and not URLs. A state S belonging to V can be represented as a set URTF, where U is the authenticated user, R is the role or permission, T is the token and or session, F represent the internal system flags. Because of this, two identical requests to the same URL do not belong to the same node if any of these parameters differ. For example, a request like get slash admin made by an authenticated user and the same request made by an admin user are synthetically the same request but represented different system states and therefore different nodes. From this point of view, we can think of Dust as a graph exploration problem. Formally, a Dust implements a function, in this case, is scan from G to G prime, where G is the real graph of the system and G prime is the explore subgraph. There is no guarantee that G prime is connected and that G prime contains critical nodes or G prime is equivalent to G. Just to remember, a connected graph is a graph which every node is reachable from every other node through some path. So we can say that coverage is not security. The true notion of coverage would look like this, the equation that we have in the screen. However, the absolute value of V is unknown. The absolute value of V grows exponentially because the system is a Cartesian product and not a list. Meanwhile, the absolute value of V prime is small and biased. Because of this, coverage is not a measurable in absolute terms. This is a MP type problem, fully exploring the graph imply visiting all reachable nodes under finite time constraint. This reduced to a problem of exhaustive state exploration with a high branching factor. It is a NP hard due combinatorial explosion, even through it is not formally reducible to a SAT. Just to remember, SAT means to Boolean satisfiability problem. It is the problem of determining whatever there exists an assignment of Boolean variables that makes a given logical formula evaluate to true. It is a canonical NP complete decision problem and is commonly used as a reference point for computational hardness. So instead of crawling everything, we should prioritize nodes with higher degree, higher centrality, and higher transition fan out. This is equivalent to maximizing information gain per request. Now, for CI/CD pipelines, what does dust past actually mean? It only means no vulnerabilities were found in the explored subgraph under the initial conditions. A mature pipeline asks different questions. For example, which region of this state space did we cover, and which assumptions did we make explicit? In conclusion, in a world where modern and large applications are constantly pushed to improve security, Dust is not just a tool. It is a mathematical problem of partial exploration, and security stop being a ritual and becomes true engineering.